Hello everyone. Last video we learned about geometric trigonometry, like finding the area of a triangle, finding the different lengths and angles with cosine and sine rule. Now we go on to my favorite part of trig, and the main bulk of trig, which is algebraic trigonometry. First off, let's learn about trigographs, which is the graphs of all the trigo functions. We have sine x, cosine x, and tangent x. Before we start, if you're not familiar with transformations, please watch the video on transformations first. This is in topic 2, functions. Transformations is very essential in understanding how trigonometric graphs work. Okay, so now that we have that out of the way, let's start on trig graphs. Let's focus on the sine graph first. Over here, we have the graph of y equals to sine x. What you can see here is the graph goes up from 0 to 1 at pi over 2, and then it goes down at pi, and then it goes down even more, and then it goes back up again. Actually, I've only displayed one cycle here. If I don't restrict the domain, this goes on infinitely many number of cycles. This is the second cycle, third cycle, fourth cycle, fifth cycle, and on and on and on. And of course, it also goes in the negative direction. Okay, now let's look at the graph of y equals to cosine x. Don't worry about the amplitude and period first, we'll talk about that a bit later. The graph starts from 1, and then it goes down to 0 at pi over 2, then it goes down even lower to negative 1, and then it goes up and up again, reaching 1 at 2 pi. If you look at this very carefully, the graph of y equals to sine x and cosine x look uncannily similar. Actually, the graph of cosine x is just the graph of sine x but translated pi over 2 in the negative x direction. If you see what happens if I move this sine x graph to the left by pi over 2, I will get a graph that looks something like this. And if you can see, this shape resembles the cosine curve. Now there are many identities when it comes to trigonometric functions, and some of the simple ones are good to know. Here are all the fundamental identities that you should know, but all of these can actually just be derived. But in case you're not familiar with deriving them, just remember these. These are very useful to know. In case you want to know how I remember these, I kind of just remember by, oh, this one tangent is the odd one out with 1 over tangent. For this one, sine is the only odd one out because it's positive. And here, for the negative angle formula, cosine x is the only odd one out. In this case, because it's an even function, if you remember your even functions. But really, these identities will probably be tested like once or twice, and if you don't want to remember all of them, it's also okay. Before I continue, please remember the shape of the y equals to sine x and y equals to cosine x graphs. This is really important. Now the last graph is not so important in IB, the graph of tangent x. It looks something like this. Now before we continue to the transformations of graphs, let's take a look at what the amplitude and period is. The amplitude, which I'm going to highlight in green, is the vertical distance from the center line to the maximum. What does that mean? For this trigo graph, we can see that the center line is over here. And this one, the center line is over here. The vertical distance from the center line to the maximum is 1, and hence the amplitude will be 1. Oh, and this can technically also be the vertical distance from the center line to the minimum. So this distance from the center line to the minimum is also 1. And remember, I want the amplitude to always be positive, so I can't give a negative value for the amplitude. The next definition we need to know is the period. I'm going to highlight this in green again. It's the length of one complete cycle. So remember when I drew the graph of sine x infinitely with so many cycles, the period is only concerned with the length of one of these cycles. So this cycle over here has a length of 2 pi, and hence your period is 2 pi. Similarly, for the graph of cosine x, the length of one complete cycle is also 2 pi, because after this, the graph will repeat another cycle, and another cycle, and another cycle, and also for the negative side. So we just say that the period of these two graphs is 2 pi. Okay, now let's look at the transformations. I know some of you may not really like transformations too much, but it's very important to understand how transformations can impact trigonometric graphs because it's a very popular question in exam. First up, let's look at the stretch on the y-axis. Let's say we have the graph of y equals to 2 sine x. If you remember your table of transformations, this is a stretch on the y-axis by a factor of 2. So basically, this means that the y value of each point gets doubled, which you can see in the blue graph here. Now, you also realize one thing, the amplitude is no longer 1. The amplitude is actually 2. If you look at the center line to the maximum, this maximum point is now doubled at y equals to 2. So this length from 0 to 2 is just 2. That's why your amplitude now is 2. We are done with stretching on the y-axis. Now let's do stretching on the x-axis. Now, from sine x to sine 2x, if you remember, x is a rebel. So this is not a stretch by a factor of 2, but a stretch on the x-axis by a factor of half. This means all the x values over here get halved from the black graph to the blue graph. If you realize, the graph now has a period of pi. This over here, this one cycle, is actually from this one cycle over here that I'm highlighting in yellow. This extra blue part over here is actually a new cycle, a second cycle that I just added in to show you that the graph gets compressed into that. Now if you realize, the graph now has a period of pi, it's no longer 2 pi. This part over here is a second cycle. So the length of this new cycle is just pi. Next, we will have the translation in the x direction. Again, x is a rebel, so sine x plus pi over 6 is actually a translation of pi over 6 in the negative x direction. If we look at the period though, the period does not change from a translation. We see that the cycle starts from over here instead, but ends earlier on. So the period is still 2 pi because the length of this cycle is still the same. Similarly, if we have a translation in the y direction, this does not affect the amplitude. Even though the maximum point is now at 2, remember, the amplitude is the vertical distance from the center line to the maximum. The center line is now at this green line here, at y equals to 1. If you look, this is the center line of the new transformed trigograph sine x plus 1. So this distance, this orange distance that you see over here, is just still 1. So the amplitude is still 1. To represent all that into a really nice compact formula, I have all these letters written over here. A sine bx plus c plus d. Your amplitude will just be the mod of a. Again, your amplitude needs to be positive, and your period will be 2 pi over b. Again, if you look over here, y equals to sine 2x. We are stretching by a factor of half, so your period becomes halved. So in this case, for a stretch factor of b, we want to divide by b. With that in mind, let's solve a very typical IB question. Let's look at this. The first high tide is 3 AM and the first low tide is at 7 AM. High tides and low tides are water depths of 10 meters and 4 meters respectively. Given that T is the time in hours after midnight, find the possible values for this to model the water level H. So this is a sine graph, so it should look something like this. Again, this is at 3 AM and we want this to be at 7 AM. Since T is the time in hours after midnight, so this point is T equals to 3 and T equals to 7. We know that the height of this is at a water depth of 10 meters and this one is at 4 meters. So we can kind of tell what the center line is, and in this case, the center line would just be 7 meters. Right, this line over here is at 7 meters. So we can instantly tell that D equals to 7. D will be your center line at 7. A will be your amplitude. Now you can give A as a negative value, but usually we like to give A as a positive value. So over here, your A, your amplitude, will just be 3 because it's the distance from the center line to the maximum. Now your period, even though they give you 3 AM at 7 AM here, your period is not 4. If you look at the graph, the entire length of this cycle, this red thing over here, is not 4. 4 is only half the cycle. So actually, your period is 8. So we know that 2 pi over b, using this formula up here, 2 pi over b equals to 8. This means that b equals to pi over 4. Now, we are left with one more value, and I kept this for the last because it's a little bit tricky. If let's say we have a point Q, after we do the transformation using this, the new transform point will actually be P minus C over B, comma, AQ plus D. Right now though, we only want to focus on the X value that's being transformed. And that's because we want to focus on the translation over here, C, which is in the X direction. The reason why it's P minus C over B is usually I want to do the translation first, so I'll do P minus C. Remember, X is a rebel, so I do need to take the negative sign. And then over B, because X is a rebel again, and the stretching will be a factor of 1 over B instead of B. P becomes P minus C over B after the transformation. So if you look at the original sine graph, this part is when X, or if you want to say T, is equals to pi over 2. And this point becomes T equals to 3. So we know that pi over 2, which is the old point, minus C over B will be equals to the new point, which is at T equals to 3. And we know B is simply pi over 4. So if we solve this, C is actually equals to negative pi over 4. We are just substituting a value of X over here from the initial point to the new transform point. In this case, T equals to 3. But we could sub in a value of, let's say, 3 pi over 2 being transformed to T equals to 7. That's also fine. Actually, this is only just one value of C. There are a lot of possible values of C. And the reason why, if you would like to know, is because the graph of sine is cyclical. And that's why when you translate it, you can have many possible X values of translation. But anyway, we can just stick to this method to find a possible value of C as negative pi over 4. Here's a summary sheet for trigonometric graphs. Thank you so much for watching.